Okay, so here we have a difference of two exponential functions, and we want to find the absolute maximum and minimum. So as usual, we're going to first find the critical points. So that means we need the derivative. So the derivative of this one, well, that's just, here we would have e to the negative x times the derivative of the top, which is -1, so I'll just put it in front, and then minus e to the -2x times the derivative of the top this time is -2, and so if I multiply it by out here on in front, this would turn it into a +2. Okay, so this is my derivative, and we know that this function is never undefined, so we just need to find where this function is equal to 0. And so to solve this, well, probably the best thing for us to do is to factor out an e to the -x. And if we do that, what we're going to have is a -1 and then plus 2 times e to the -x. Okay. And we need to figure out when this guy is equal to 0. Well, we know that e to the -x is never equal to 0. So never equal to 0. But we can solve this guy inside. So let me rewrite it a tiny bit. What we have is 2 times, let's write it as 2, instead of e to the -x, let's write it as 2 over e to the x. -1 equals 0. Okay, so if I combine the two fractions, this guy needs an e to the x, top and bottom. So really this equals 2 minus e to the x all over e to the x is equal to 0. And since e to the x is never equal to 0, I can multiply both sides by it. And so they'll cancel here, and this right side is going to equal 0. And so now what I have is I need to figure out when e to the x equals 2. And if I just turn this in from exponential to a logarithm, what this means is that x is equal to natural log of 2. And so this is my one and only critical point. Sorry about that. Okay. So that's good, and so now I can compare the value at the critical point with the values of the endpoints. So what we're going to have is a natural log of 2. So we're going to plug that in, so we're going to have that y is equal to e to the negative natural log of 2 minus e to the -2 natural log of 2. Okay, so this looks very complicated, but let me rewrite this using the laws of exponents. I can write this as e to the natural log of 2 all raised to the -1 minus e to the natural log of 2 all raised to the -2. Because remember, when you raise a power to a power, you multiply, and so that's just using that property backwards. Okay, but then e to the natural log of 2, well, that's just 2. So really what I have is that this is equal to 2 to the -1 minus 2 to the -2. Well, this is just 1/2 minus 1/4, which is just 1/4. Okay, so now let's plug in the other ones. So if I plug in 0, y is going to equal e to the 0 minus e to the minus 2 times 0. Well, this is just, e to the 0 is just 1, e to the 0 is 1, so this is just 1 minus 1, or 0. When x is equal to 1, y is equal to e to the negative 1 minus e to the negative 2. And this one we can approximate using the calculator, and we would get approximately 0.23. Okay, so if we look at all of these and compare them, we know that this is going to be our absolute minimum, and 0.23 and 1/4, well, 1/4 is 0.25, so this is our absolute maximum. So let's rewrite this in one place. Our absolute maximum is going to occur at natural log of 2 1/4, and the absolute minimum is going to occur at 0 0, and that's our absolute minimum.